morning. My name is Jacques Raphael, and I have created a channel which is called Economic Experts. And I have been uploading videos in Greek. I'm a professor of economics, finance, and econometrics, and I own one private college in Athens. From now on, I will be uploading these videos which are associated with the field of economics, finance, econometrics, statistics, macroeconomics, microeconomics. I'll be uploading these videos in English so that foreign people from abroad, are able to watch them and derive very useful knowledge. These videos, I repeat, will be referring to the field of economics, macroeconomics, microeconomics, econometrics, statistics, finance, accounting, and etc. Today, I will upload a video which has to do with econometrics and, to be more specific, with the multiple regression model. In the multiple regression model, we have one dependent variable and several independent variables, and we want to determine the statistical impact of these independent variables on the dependent variable. The regression will be performed in the SPSS program. Let's see now our example. Our dependent variable is wage, and we want to determine the statistical impact of experience and rating at work. And when I mean rating is when I mean rating, when I mean about rating, I want to say that how people are evaluated from their supervisors. Rating in this case means their their performance evaluation. They refer to the performance evaluation. We want, therefore, to determine the statistical impact of rating and experience on wage. Therefore, through the multiple regression model, we are going to estimate B0, B1, and B2. These are the coefficients of the regression. And we are also going to check the statistical significance of these coefficients to see whether the statistical impact is statistically significant or not. So what do we do? This is the general form of the regression to be estimated. We go now to the SPSS program, and in the variable view, one moment, let me find the proper program. In the variable view, we insert the variable of wage. In the variable view window, we name the variables each: wage, which is the dependent variables; working experience of employees; and their rating at work, which measures their performance. I want to point out that the rating ranges from 0, which means that the employee has a very bad performance, until 10, which means that the employee has an excellent performance. He has received, in this case, the best possible evaluation. We go now to the data view window, and we insert the numerical values of each variable. Here we have the wage, the working experience, and the rating. We have selected a sample of 17 employees. The wage expressed in $1,000 per year. Working experience is expressed in years, and rating takes values from 0 to 10. And as I mentioned before, 10 represents the best possible performance at work. We have selected a sample of 17 employees, and through this sample, we want to draw conclusions regarding the coefficients of the regression. We have the B0, which represent the steady coefficients; B1, which represents the variable of the the coefficient of the working experience; and B2, which represents the coefficient of rating. We have also the error, which represents the difference between the observed value of the dependent variable and the estimated value of the dependent variable, which in our case is the weights. After having inserted these variables, we have to run the regression. We go into Analyze. I remind you, we are performing this regression in the SPSS program. We go to Analyze, Regression, Linear, and then we pass the variables. The dependent variable, as we mentioned before, is the weight. So we insert it in the dependent window. The working experience is our independent variable, one of the two independent variables, and we insert it here. And the rating is the other independent variable. We have also other options regarding the regression. In statistics, we can estimate the descriptives. We don't need to estimate out the descriptive statistics of those variables. We shall focus only on the results of the multiple regression. We can click the confidence interval. We have also other choices, but here we focus on the multiple regression itself. And to be more specific, we want to estimate the coefficients of each independent variable together with the steady variable. With the steady term, B0 represents the steady term, and we also want to check out the statistical significance of these coefficients. In the Save option, we can click the unstandardized predicted variables. Predicted variable shows us which the weights will be based on the specific values of the independent variables, and this level of weights will be determined according to the regression estimated. We also click the residual window to find the residuals of the regression. We don't have to click anything else. We press continue, then OK. And as you can see, now we have the results of the regression. First of all, the coefficient of determination is equal to 0.66, if I can see well, to 0.66. This means that the 66% of the variability of weights is explained by the independent variables. This in turn means that the equation has a satisfactory explanative means that the regression has a satisfactory explanatory value. It means that the independent variables indeed explain to a great extent the variability of the dependent variable. In the ANOVA table, we can observe the F statistic. The ANOVA table, through the ANOVA table, we can check the statistical significance of the equation. In other words, we can check out the hypothesis. The null hypothesis is the steady term is equal to the B1 is equal to B2 is equal to 0. And the alternative hypothesis is at least one of the coefficients of the dependent variables is different from 0. And this, the statistical significance of the equation is being checked through the F statistic. We are not going to focus on the value of the F statistic, but on the p-value. If the p-value, which is being named here sig in the SPSS program, if the p-value is smaller than the level of significance, then we reject the null hypothesis that the coefficients are equal to 0, and this equation is statistically significant. If the p-value is larger than the level of significance, which is equal to 0.05 or elsewhere to 5%, then we do not reject the null hypothesis, which means that the equation is not statistically significant. There is not any specific relation between the dependent and the dependent variables. This is what a p-value larger than 0.05 means in the case of the ANOVA table. Here we can see that the p-value is smaller than 0.05, which in turn means that the equation is statistically significant. There is a statistically significant linear relation between the dependent variable y and the independent variables. Now let's see what happens with the coefficient table. Here we can see how we can observe the values of the coefficient. The constant or steady term is equal to 0.08. The p-value is equal to 0.82. This is larger than the level of significance, and this means that the constant is not statistically significant since it has a very large p-value. The working experience is equal to 1.52. This means that if the working experience increases on the margin and the other independent variable remains steady, then the annual salary will increase by $1,500. And when we say that the working experience increases on the marginal, it means increases by, let's say, by 1 year. The p-value of this independent variable is equal to 0.008. This is much lower than the level of significance. So the working experience has a positive and statistically significant impact on the dependent variable of wage. The rating, which in this case, the performance of the employee is being measured, is equal to 1 point, as I can see, 89. This means that if the working experience increases, if the rating increases marginal, let's say from 7 to 8, then the annual salary will increase by almost $2,000 per year. As we said before, the wage is expressed in dollars on a yearly basis, in $1,000. However, the B2 coefficient of the independent variable, which in our case is the rating, is not statistically significant since the p-value is 0.24, which is much bigger than the level of significance. So the working experience is statistically significant as a variable, which means it has a statistically significant impact on the wage, while the rating is not statistically significant, which means it doesn't affect on a statistically significant way the dependent variable of the wage. The form of the regression will be the following: wage is equal to yes, to 2.08 plus 1.52 working experience plus 1.89 rating. This is the mathematical form of the regression. Here, as we can see, the coefficients are being estimated through the OLS method, or OLS means ordinary least squared. Here we can see the confidence intervals. For instance, in the case of the working experience, the coefficient ranges from 1.46 to 2 point to almost 2.6. We can see that the value of 0 is not being included in the confidence interval with a probability of 95%, and this is an alternative way to reject the null hypothesis. So with a probability of 95%, the coefficient of the working experience will range from 0.4546 to 2.59 to 2.59. By 95%, with a probability of 95%, the variable B1 will take one of those two values. We don't, one of these values, which range between the lower bound, which is this, and the upper bound, which is this. We don't know exactly which the values will be, but we know that they will lie on this range. Finally, as we can see in the SPSS program, we have estimated the predicted values. This means that with a rating of 8 and a working experience of 12 years, the employee will be earning on average almost $36,000. An employee with a working experience of 9 years and a rating of 7 will be earning on a yearly base and on average almost $30,000. Thank you very much for watching this video. We have showed how the simple regression model is being estimated in the SPSS program. My name is Zach Raphael. This is the channel of economic experts. Stay tuned to this channel since we'll be uploading many interesting videos which relate to finance, econometrics, economic statistics, accounting, etc. These videos will be uploaded on a quite frequent basis. Thank you very much. Have a good evening. Thank you.